How many highlighters do we need?
Just one.
I get it.
Just one, okay.
He'll learn something
Alright, here we go. Okay. Unit circle. Okay. Again, it has a radius of 1, okay? And right now, we are going to focus on, the quadrant angles. So this is what I'm going to highlight. Just the X and Y axis. Because from yesterday, if you remember, the quadrant angles, they lie on the axis. So these are the 4 that we're going to focus on right now today.
Oh, so what's the difference? If we're not gonna focus on them, so do they have like names? Like probably
Just let me do it at my speed.
lightning.
Lightning speed. Another unit circle.
I need many unit circles.
I made a
Mini.
few extra.
This has been the worst dream.
I got off track. I got excited. I went over this with a black Sharpie earlier.
Alright, here we go. Hey, now, quadrant angles are going to lie on the axis. So this is the X and Y axis, okay? So this is kind of like the origin right here in the middle. So if this is the origin, this point right here, first of all, how many degrees is that? We talked about this yesterday.
From what?
Right here.
That
This was 0 degrees. And in radians, it's going to be 0 radians. And what are the coordinates of this point? If I were to count from the origin here and plot this point, what would the coordinates of that point be? 1, 0. So can you tell me what the sign of 0 is?
0.
0. Can you tell me what the cosine of 0 is? 1. Okay. Okay, let's go over to this other side here. Oh, actually, let me say this real quick. What all the way around the circle is 360 degrees, but in radians, what is it all the way around the circle? 2 pi. So this is also 2 pi. Okay, so we're going to go across here. So if all the way around the circle is 2 pi and 360 degrees, first of all, in degrees, what is this going to be? 180 degrees. In radians, what is this going to be? This is 2 pi, so this is going to be 1 pi, which is pi. What are the coordinates of that point? -1, 0. So right now, did you know that you could tell me what the cosine of pi was?
Didn't know it, but I can.
But now you can. The cosine of pi is -1. The sine of pi is 0. Don't you feel smart?
No.
My brain's still like English.
Okay, now, up here at the top, what is that angle going to be? 90 degrees. Now in radians, this is 0 pi, this is 1 pi, so this is pi over 2, 1/2 pi, right? But we don't write the 1 on top. So pi over 2. It's 1/2 pi, but we don't write the 1. And when we go through this, every single step of this, I'm explaining why it is what it is, because I don't want to give anybody a panic attack. But when you take the test, you're going to have to create your own unit circle. So you need to know why these things are what they are. Okay? So does everybody understand that this is 1 pi, so halfway is 1/2 pi? Yes? Okay. What are the coordinates of this point?
0, 0, 1.
0, 1. Okay, down here at the bottom. So if I start at 0 and the terminal side of my angle is down here on this y-axis, how many degrees is that? 270 degrees.
Quick
180 plus 90 more. Okay, now radians. So this is 1/2 pi. This is 2/2 pi, because 2 over 2 is 1, right? So what's this going to be? 3/2 pi. So 3 pi over 2. Okay, listen. 1/2,
My bad, my bad.
but you don't write the 1. 2/2, that's 2 over 2, that's 1. Does that make sense? 3/2 is down here, so 3/2 pi. 4/2, does 4/2 reduce to 2? Yes, so does that make sense logically? Because you're going to want to be able to understand that. Okay, what are the coordinates down here?
0, -1.
0, -1.
I like that question the best.
Okay, now then, what if I ask you about 7 pi? What if I said, what is, well, let me write this down so I know exactly what we're doing. What if I wanted to know, did they give me a problem here?
7 pi's according to.
Okay, here, example 3. This is what I want. Example 3. I want to find the sine of 3 pi.
That's counting.
The sine of 3 pi,
Be 0.
I don't see a 3 pi.
0.
So there's a couple different ways you can think about this. I prefer just to count it. Like if I start at 0, this is 1 pi, 2 pi, 3 pi is over here. Can you see?
Yes.
Okay, so if I start at 0, right here, 3 pi. So this is 1 pi, 2 pi, 3 pi. So 3 pi is co-terminal in the same spot as pi. Does that make sense?
Yes.
Wait, what?
Wow. One more
Because
time.
it's in the same spot.
It's in the same spot. Co-terminal is a fancy word for the same spot. Okay. What? Because we're really smart. Okay, 3 pi. Let me say this one more time. 3 pi. So here is 0 pi. Here's 1 pi. Here's 2 pi. 3 pi. So right here is really where I'm at. Now, if you don't like that, that's my preference. That's just me. That's my preference. But if you want, you can always just subtract a full circle off. So 3 pi, how many pi's are in a whole circle? 2. So you can say 3 pi minus 2 pi, and you'll still end up at pi. Now, when the numbers get bigger, I really don't like that method, but it's totally up to you. So does everybody understand that we are at pi?
Yeah.
3 pi is coterminal with pi. So if I want to know the sine of 3 pi, that's the same thing as the sine of pi. What's the sine of pi?
0.
0.
This has to be pi.
You said pi.
But you
one
have-
time
so you have to
and
write-
I
Pi.
So you have to write both?
No, but I want you to see what it is.
So 3 pi is the same as pi.
Coterminal. It's not the same. It's
No.
coterminal.
Coterminal.
Saying-
So it's also the same. It's coterminal to 5 pi, 7 pi, 9 pi.
Coterminal, yes.
The odds are on the left is what you're telling me.
Odds are on the left.
Yeah.
Yes.
Evens on the right.
Look how it's 3 pops.
Too late to drop out.
Cosine of negative 270 degrees.
It's gonna be 0.
It's always 0.
I got you, Tony. No, wait, did you
Hold on a
say
second, I got
negative?
you.
It'd be,
Negative.
the cosine would be
Oh,
0.
Is it pi over 2?
Hey, negative 270, so I'm going this way 270 degrees. So it is in the same spot as pi over 2, James Werner coming in there. So I'm at pi over 2, 90 degrees. So what was I looking for? The cosine. So what's the cosine? 0.
We're so good at this.
Okay, and I do believe that that is enough for today, don't you?
Yeah.
Yeah, I
Enough
think
for
like-
new material.
It's time to play cigarettes. It's just-
No.